So we are working into or we'll probably finish the Algebra 2 content here today. But right now we're working on the nonlinear equations, focusing again mostly on quadratic functions, and exponential functions would be the most common. Okay, so I want you to try question number 54. This is working with an equation that is not going to give you an integer value. Okay, it'll be an irrational solution. Okay, and so see if you can answer that, please. All right. So on this problem here, I'm going to talk through how to do this by hand. Again, you guys have the tools to be able to answer this question by hand, but you will also have access to your TI-89, which I do recommend, since the TI-89 will just give you the answer to this type of question. But when you're working with something like this and you're solving by hand, you either need to be able to complete the square or use quadratic formula. And to me, completing the square is always, it gives you easier numbers to work with if you're manipulating them by hand. So what I would do for this to complete the square is you isolate your x terms, move your constant over to the other side. So I'd add 6 to both sides first. And then you're going to do the process of completing the square. And if you recall, completing the square, you take half of your first degree term's coefficient, so half the coefficient of x. So half of -8 is -4. Notice I include the sign and group it. You're then going to square that value and add it to both sides. So when I add -4 squared is a positive 16. And the whole point of doing this is it allows you to rewrite your expression. When you rewrite it, you get x and then whatever this number is, including its sign. So x minus 4 quantity squared is equal to 22. And now when you extract your square root, you get x minus 4 is equal to, you always need to count for both the positive and negative of that root, 22, add 4 to both sides, and you see you have your answer in this form, right? It's 4 plus root k. Well, the value that represents k here is 22. All right, now, if you were going to do this with a calculator, which again, I strongly encourage you, bring your TI-89, even though you can use Desmos, and I'm showing you how to use Desmos. Using a TI-89 is often an easy solution for solving problems. So here, if you just go make sure you're in your regular tabs, right? If you've used custom tabs to get the system solving template, you might need to change it back. Just make sure it's the F2 Algebra tab. When you select that, solve is the very first option there. And all you would have to do for this problem is type the equation exactly as it appears. Okay, the way that you format solve is you type your equation and then put comma, identify the variable you want to solve for, which in this case is x, and then close the parentheses. And notice it gives you the solution. 4 plus root 22. This would be a 4 minus root 22. Now, if you're using this for your science classes, a lot of students I notice put their calculators in approximate mode for a science class, which gives you all answers in decimals. If you do that, you won't see this form. Down here, like you can see where mine says auto, if yours says approx right there, you can always go into this mode button. If you click mode and scroll, it's on the second page. So if you scroll all the way down or just hit F2 to jump to that second page, where it says exact or approximate, mine says auto. Your 3 choices are auto, exact, or approximate. Exact always gives you answers as radicals or fractions. Approximate always gives you answers as decimals. The nice thing with the auto mode is it gives you an answer in whatever form you enter it. So like if I wanted this answer here to be in decimal form, I could have done 2 things. Since I'm in auto mode, I could have put a decimal anywhere in my calculator in the entry. If I put a decimal point somewhere in there and hit enter, it'll give me my answer as decimals. The other thing that I could do if I wanted decimal answers and I'm in auto mode is to hit this green diamond button. Notice it gives you a little icon down here on the bottom of the display. And if this is selected before you hit enter, no matter which mode it's in, it'll give you the answer in the decimal form. Okay, so you can get the decimals in auto mode, so I would just always leave it in that mode. Okay, but the last way that I want to kind of talk through this is just to show you again the tools to use Desmos to your advantage if you come across something that you're just not quite sure what to do for it. Okay, if you know you're looking for a solution here, right? So a solution is your x-intercept. Okay, so if you type this into Desmos, it will graph it for you. The problem is, when you see the graph on here, you can actually see your answer is 8.69, 8.7 approximately, but you don't know this radical form of it. Okay, and so what you can do with Desmos is you can use regression equations to put these into any form that you want. Now remember, quadratic functions have three different forms you can use. General form, ax squared plus bx plus c. That's great if you need to know the y-intercept, I guess. I mean, or just the equation of it. Vertex form, a times the quantity x minus h squared plus k. That's perfect if you need to know the vertex. Okay, although the vertex, anytime you plot this, again, you can find the vertex here. But if it happens to be an irrational number, if it happens to be a number that's not as convenient to see, you can use vertex form. And then finally, intercept form. Okay, the a times the quantity x minus p times x minus q. So what I can do here is I can basically rewrite this equation, and I can have the regression equation pull it up as x squared minus 8x minus 6, but it will put it into that factored, or into that form where I can find the p and q values. So here's kind of what I mean by that. Okay. If you just set any equation equal to f of x, what this allows you to do is it allows you to plot points. So I'm going to go into my table. And remember, for quadratic functions, we need 3 points. So I can just choose any 3 points, any 3 x values, and then I'm going to choose f of 0. I don't have to evaluate it. I just set it up in that function notation. So 1, f of 1, it'll do the evaluating for me to f of 2. So you don't have to do any thinking on this. You just have to plug in 3 points. And then if you pull up the regression equation, y1 is similar to a times, now I want the factored form, because I want to know what the exact answer is for this intercept, not just the approximate form. So if I type in, remember, it has to be x1 and y1. So x1 minus p times x1 minus q. Okay, it pulls these up, and I have my 2 intercepts. Notice now this 8.69, I have the exact value of it represented by q. So I can pull that down. When I type in q right here, it has the full value of this. Okay, and so what I know is that basically this is equal to q. So if I want to find what k is, I would simply take q, subtract 4 from it, so minus 4. Okay, so if I subtract 4 from this, and then I need to undo the square root, so I then square this. So if I close this off and square it, it's going to give me my number. Okay, now, the reason, again, I show you this so that you understand. You can take any given equation, you can plug it into a table, you can run the regression on it, and then you can access the exact values of anything that you need based on whatever it is the question's asking. Okay? Like I said, this is a very roundabout way of solving it. Using your TI-89 is obviously the easiest way, so have that with you. You see a problem that asks you to solve, immediately just type it in your TI-89. I mean, you don't have to prove you know how to do anything to get the scores that you're looking for. Okay? Do it the easiest way, the most efficient way. All right, so try number 56 here. Continue to work. This is other types of nonlinear equations that you will likely see would be absolute values. So it is useful to be able to sort of categorize a question. When you look at a question to see, is it an Algebra 1 question? Is it an Algebra 2 question? Is it a problem-solving question, or is it a geometry question? If it's Algebra 2, most likely your TI-89 is the best bet for solving this. I'll come back and do that here in a second, but if I was doing this, I'd probably use TI-89. Okay, but I'm going to show you how to do this by hand really quickly. So notice you have these same two values inside absolute values. And so what you can do is you can just combine their coefficients. And 6 times the absolute value of 4 minus x plus 8 times that same thing is just 6 plus 8, or 14, times 4 minus absolute value of 4 minus x equals 126. And then if you solve, you can divide by 14. So 126 over 14 gives you 9. And if you're, remember, solving for absolute values, you're going to split what you have. Each one begins with exactly what's inside the absolute value. On one side it's the positive, on the other side it's the opposite of what's written. And then you just solve. Now it's asking you for the positive solution, so we need the one that winds up giving you a positive answer. It's like, maybe it's a little counterintuitive here, but when you solve, since there's a negative in front of your x, subtract 4 from both sides. That gives you a negative 13. Change the sign. So 13 is going to be your answer. If you had done it over here, you would get negative x equals 5. Change the sign. So negative 5 and 13 would be your two answers, but it wants the positive one. Okay. If I was being asked to solve this, again, what I would do is I would just immediately go right to the TI-89. Use the solve feature, the F2 algebra tab, choose solve. In the TI-89, this vertical bar right here is called a with key. Okay, it's not an absolute value symbol, so it doesn't represent absolute values. If you want to do an absolute value, you can do one of two things. You can type in the letters ABS, which is what I would probably do. I just hit this white alpha key twice. Notice the first time I hit it, an A appears right here. Second time I hit it, it's a block over the A. That means it's locked in alpha mode. And so I would just type A, then B, then S for that. The other way you can do this too is you can find that in this math catalog. So the math catalog is accessible right here with the blue second button and then 5. So if you hit that, under number, absolute value is this second option. Now, if you think about the number of keys that I just hit to get to that, right? I hit 1, 2, scrolled 3, down 4, hit enter 5 different keys. Whereas if I just alpha lock and type ABS, I mean with the parentheses, it's about, if you understand the code for it, it's easier to just type that. But if I type the absolute value of, let me go in front of that, 6 times the absolute value of 4 minus x, close that off, plus 8 times the absolute value, again I'll alpha lock, ABS, deselect that to get my parentheses, 4 minus x, and then that's all set equal to 126. In the solve feature, you're going to hit comma x to identify what you want to solve for, close it off, and when you do, you get your two answers, 13 and negative 5, which is what confirms what we got by hand. You want the positive of those to be 13. Okay. All right. If you type this into Desmos, again, just to go through all the different possibilities, remember Desmos can also use ABS. So 4 minus x plus 8, absolute value of 4 minus x, and that's equal to 126. Notice when you do that, on this, if you zoom in, you can see where your answer is, right? You can count it, 10 plus 1, 2, 3, gives you 13. But all right, so try 58. Similar idea. This one's isolating a specific unit from a formula. Again, a pretty common type of question on SATs. So when you are solving this, it's just a matter of performing the order of operations in reverse to isolate n. So we need to move the other term, the 9, to the other side. So if we subtract 9 from both sides. Okay, and then here we need to get the n out of the denominator. So if we multiply both sides by n, we get it out of the denominator. And now to isolate it, we need to divide both sides by that whole binomial, p minus 9. And when we do that, it gives us our answer, which is going to be this last option. Okay, now, you can still use your TID9 to answer these types of questions. Okay, so if you're working with the TID9 on this, what you can do, you can use other variables beside x. Okay, so if you type in the given equation, here you can find the letter keys. You can access them by hitting the alpha key and then the corresponding key with the white letter above it. So here p is equal to 9 plus 17 over n. So again, use the alpha key to represent that. And if you want to solve for n, just hit comma n, and then close that off, and it will give you the answer in those forms. All right, here's the one thing to be really careful of. Right, if they had something like this, okay, so if they asked you to solve for n, okay, if you tried to do this on a calculator and you just typed in exactly what they give you, so let's say I typed this and I wrote p n plus n equals 9, and I wanted to solve for n. Okay, when I hit enter on this, I mentioned it before, okay, the TID9 doesn't understand implied multiplication. Okay, it doesn't know that you're trying to say that p is multiplying times n here. It's going to think that pn, that two-letter combination, is its own variable. So like if I solved this, it's going to isolate the n but not treat pn as even being part of that. So if you do have two letters back to back and you're typing it in on your TID9, you have to explicitly multiply. So now if I typed p times n and ran this, it would do it correctly. And so just be aware of that. Again, it's a limitation of the TID9. It understands implied multiplication from a number to a parentheses or from a number to a variable, but it doesn't understand it if you have a variable to a parentheses or a variable to another variable. All right. So this next question here is another one of the questions that is considered very difficult. It's a new type of question. This is one, again, that is not similar to anything really that I've ever taught in a classroom setting until, again, it started to show up on these. And so this is a problem where you have a system of equations that has a linear form and a quadratic form. And what they specifically tell you is that this solution is going to be one solution, no solution, or more than one solution. Okay, and so notice here it says they meet at exactly 1 point. Okay, what this means is when you solve this system, you can find that unknown variable, in this case a, by looking at by combining them into one equation, just like you normally would, right? If you have a system of equations, you can set them equal to each other. So we could set these y's equal. So if I took this and wrote 5x squared minus 27x plus 49, and replace this y with the corresponding expression 3x plus a. Okay, so what you would do is you would work to solve it like this, but then when you're now solving this quadratic function, you're going to rely on its discriminant. Okay, because if it has exactly 1 point, then that one solution, that means that the discriminant is equal to 0. And that's how you're going to solve this. So if you then move everything to one side, right, set up this as a quadratic equation. So if we subtract 3x from both sides and we subtract a from both sides. So we get 5x squared minus 30x plus 49 minus a. This is all the constant. And set that equal to 0. If you set this up, once you get it into this form, what you now have is here's my a value, my b value, my c value, and you can use the discriminant to solve this. if we take our b squared minus 4ac, set it equal to 0, since there's one single solution, this is how you will answer this question. Okay, because our b value is negative 30, so we get negative 30 squared minus 4 times our a value is 5, and our c value is 49 minus a. And if we know that all equals 0, what we can do here is we can combine all of these equations here. If you are working through the equations on this. Okay. So here you would take negative 30 squared is 900. Here minus 20 times 49 minus a. And what I'm going to do is, before I actually start working through and distributing, I'm just going to move this whole negative value to the other side. So I'm going to add 20 times 49 minus a to both sides. That's just going to make what I have to do here a little bit easier, because now I can divide by 20. The factors of 10 cancel. 2 goes into 90 45 times. And then I can subtract 49 from both sides. When I subtract 49, I get negative a is equal to negative 4. Change my signs. And this allows me here to solve my answer. Oops, let me come back to this. Solve my answer quickly. Now, here's the problem, and be really careful. Okay? What did I just solve for? I solved for a. So a is equal to 4. What did the question ask me to solve for? X. And now you see that the answer for A is one of the distractors, one of the answer choices. Okay, that is likely going to happen. So again, on a problem like this, be really careful. It's a hard problem to do. If the answer, if you come up with the answer, just double check it and see, am I solving for what's being asked? The fact that I'm not just means I now have to plug this into the equation to solve. Okay, and so now you can use your system solving template or this to solve it. So because I have my TID9, I am going to go into my system solving template, custom tabs, second home, brings up my F3 system solving template, and then I'm just going to type these two equations. So I have y equals 5x squared minus 27x plus 49. And then my second equation is y equals 3x plus 4. And when I solve this, I get my value. X is 3, y is 13. Notice there is my answer. All right. So this is the math that they expect you to be able to do for this problem. Again, it's a challenging question. Okay. What I want to do is, I'm not 100% certain, but I'm pretty sure I can do this on the Desmos as well. So let's take a look. We can graphically solve systems of equations on Desmos. If we just type in the two given equations here. And notice, I used A before. We haven't solved this yet. I'm using A. I'm just going to create A on here, and then I'm going to visually take a look at this. All right, so what do I know has to be true of these two lines based on this problem? They intersect how many times? Once. So what I can do here is I can slide this until I see that intersection. And notice I expect A to be what it shows right here. It says a constant, but I expect it to be an integer. So right here, I see that I have this one intersection, right? And when I look at this intersection, what's the point? 313, which is what I did in this long set of algebra calculations. Okay? So get familiar with Desmos. be creative with it. Find out, like, I mean, if there's ways to visually solve things, like this right here, took far less time. Okay? It's not, I mean, maybe it's not as, like, you don't necessarily have the confidence level that you got the right answer, but again, you're balancing the time and efficiency with that confidence level. Okay? And the more that you practice using this, the more comfortable you will be. All right, so try question number 62 on the next slide, please. All right, when you scan answer choices, which is always a good initial strategy, you know that one of these has to be the right answer. So one way you can solve this is you can simply plug all these points in and see which one gives you solutions for both. Second, because it's graphical, you can just type both of your equations in, and then you can look to see where is it that they intersect. Because Desmos will, it'll highlight where the intersection of graphs are. So I see one solution is right here, 3, 0. There's, like, that's what I'm looking for. Here's my other solution is 0, negative 15. So 3, 0 is the one that would give me my correct answer. Okay. All right. What I want to do, because these are some of the harder type of questions, I do want to review these even though they're odd questions. Okay, I want you to try the top problem. So notice that in the notes here, you can see you're using, for these two problems right here, they're not really systems, but they're quadratic functions. Okay, and you are using the discriminant for these. So if you are shown that a quadratic function has infinitely many solutions, no solution, then if you are shown that it has a no solution or has more than one or just one, you can use the discriminant to find those. So try just this top one first. And can you find what value of k would make this so that there is no solution? So no solution means that your discriminant has to be a negative number, right? That's the part that's in the square root. You can't have a negative number in your square root. So what I would need to do here is to find what the discriminant is, I need to expand this out. Okay, so expanding this, I get kx squared minus 36x. I'm going to move this constant over, so plus 36, set it equal to 0. So once I set this up, I can now rewrite this, I can now identify the b squared minus 4ac, and I know that that has to be less than 0, has to be a negative number. And so here's my a value, my b value, and my c value. And so if I take 36 squared minus 4 times my a value is k, my c value is 36. And so when we solve for this, again, the 36 squared was 1296 minus the 144 k is less than 0. So if I add 144 k here and divide, so all of this divided by 144 gives me 9. So I know that k has to be greater than 9, and so it's asking me what's the least possible value of k. So can k be 9? No. So it has to be greater. What's the integer value, the smallest integer greater than 9? And so your answer would be 10 for that. Okay. So using the discriminant is a method for being able to solve these solutions with quadratics. Try this question right here. See if you can find for which of these values, so b, will this have more than one real solution? Right. If you are using the math ideas, the SAT is supposed to be testing, you would use this discriminant. It's got more than one real solution. That means that it has to be greater than 0, has to be a positive number. So if you take your b squared minus 4ac and make that greater than 0 and solve, that's the mathematical way to solve this. So here's your a value, your b value, and your c value. So here we get b squared minus 4 times a is 9, c is 25, greater than 0. So I'm going to just add this whole quantity over here to the other side. So I get b squared is greater than 4 times 9 times 25. Okay, and so if you're solving this, you get b squared is greater than 900. All right. Now, if you are thinking that you just square root both sides of this and that gives you your answer, b is greater than 30, and you're missing something. You guys recall when you were solving quadratic inequalities, that setting up like a little chart with the plus and minus signs? Did you guys ever set it up that way? All right, if you are solving this as a polynomial, as this quadratic, I'm going to kind of restart over here. So if I get b squared, I'm going to move everything to one side, and I'm going to solve this by factoring. So here I get b plus 30 and b minus 30. You guys remember setting, here's your two possible critical point zeros. My factors are b plus 30 and b minus 30. And you go through and you evaluate, are these intervals positive or negative at those? So if I pick any value to the left of negative 30 for this factor, when I'm testing whether it's a positive or a negative, anything to the left is a negative, anything to the right is a positive. Do the same thing here with this top factor. Anything to the left of it's 0, 30 is negative, anything to the right is positive. And so you can evaluate the intervals by just multiplying. A negative times a negative is overall positive. Negative times a positive is negative. Positive times a positive is positive. So you want the values that are greater than 0. So those fall in two intervals. It falls everywhere to the left of negative 30, everywhere to the right of positive 30. So either an open dot or a parentheses here. Those are your solutions, right? Negative infinity to negative 30. 30 to infinity, if you were finding the area, the domain where this is true. So what we're looking for is which of these numbers fall into that area, into this range of, or domain of answers. 30 is no, because it's not included. 15 falls somewhere in this middle range, no. 5 falls in that middle range. Negative 35 falls here, which is in one of our solution intervals. So if you're solving this with the math, you do need to, like you might have tested points. Again, I set up intervals and just evaluate the sign. Okay, now, as I've done with some of the others, there's an easier way to look at this potentially using your graphing calculator. Okay, so if we plug this into the graphing calculator, 9x squared plus bx, again, we're going to rely on a slider here. Okay, I can see this. Now, when I look at this with I need to just test 4 different values for b, right? So I'm going to take 5 to start with. When I plug in a 5, how many solutions do I have for this graph? A solution is how many times it crosses the x-axis. When b is 5, there's no solutions, right? So if I go down to negative 35, how many solutions are there? 2. Is that more than 1? Yeah, so there's my answer. This is how I would solve it, kind of understanding how things work. But I can verify the other ones too. Let's test 15. How many solutions? 0. And then let's test 30. How many solutions? 1. And you want the one that had the more than 1, which is the negative 35.